Hi everyone, my name is Dorcas. Me and my group members who are Karl, Suen, and Fariz are going to go through the investigation for transformation of graphs. We are going to talk about the transformation of graphs in 4 types of functions. The first one is linear functions, second one is quadratic functions, the third one is cubic functions, and the fourth one is square root functions. First of all, I would like to share my investigation about linear functions. Linear functions is a function which forms a straight line in a graph. The equation for this function is fx equals to ms plus c. M is a gradient, c is a y-intercept. Now I'm going to talk about the translation in linear functions. There are 2 function notations stated, which are fx plus a. The difference between 2 of the function notation is that one of the plus a is outside the brackets of x, but another plus a is inside the bracket of x. The first function notation, which the plus a is outside the bracket of x, means that it is a vertical translation upwards for a units. The coordinate point will change from xy to x and y plus a. And the second function notation with the plus a inside the bracket of x, it means that it is a horizontal translation to the left for a units. The coordinate point will change from xy to x minus a and y. The second transformation is reflection. The first function notation for reflection is negative fx. When the negative is in front of the fx, it means that it is a reflection in x-axis, and the coordinate point will change from xy to x and negative y. The second function notation is f negative x. When the negative is inside the bracket with x, it is a reflection in y-axis. The coordinate point will change from xy to negative x and y. Now let's look through the example of translation. The first graph shows a vertical translation. The green line represents the original function fx, and the purple line represents the translated function fx plus 2. When the plus 2 is outside the bracket of x, all the coordinate points on the green line will move vertically outwards for 2 units. So for example, the coordinate point 0, 0 will become 0 and 2. And the second graph shows a horizontal translation. When the function fx plus 2 and the plus 2 is inside the bracket of x, it means that all the coordinate points on the green line will move horizontally to the left for 2 units. For example, the coordinate point 0, 0 becomes negative 2 and 0. And followed by the example of reflections. In the first graph, it shows the reflection in y-axis. The original function fx is reflected into negative fx. So for example, the coordinate point 10, 10 will becomes 10 and negative 10. The second graph shows the reflection in x-axis. The original function fx is reflected into f negative x. So for example, the coordinate points 10, 10 will becomes negative 10 and 10.
Hi, I'm Yushen, and I'm going to talk about the quadratic functions. And here is the equation that we normally use for the quadratic functions, which is fx equals to a brackets x minus h brackets square plus k. And the a indicates the reflection in the x-axis or vertical stretch or compression. And the h indicates the horizontal translation, and the k indicates the vertical translation. And moving on to the examples, the first one is the horizontal translation, which positive, you move to the left, and if it's a negative, you move to the right. For example, the blue line, which is x plus 3 brackets square, you move the line to the left by 3 steps, and the green line, which is x minus 3 brackets square, you move to the right by 3 steps. And the next one is the vertical translation. If it is a positive, you move upwards, and if it's a negative, you move downwards. For example, the black line, which is x squared plus 2, you move up 2 steps, and if the red line, x squared minus 2, you move down by 2 steps. And the next one is the reflection. And the original line you can see is the purple line, which is fx equals to x squared. And if you want to reflect the line, add a negative in front of the x squared, which you can see the blue line is the opposite of the purple line. And the last one is the stretch and compression. If a is more than 0, it is stretching, and if a is more than or less than 0, it will compress. For example, the blue line, which is fx equals to 5x squared, you can see the line is stretching, and the green line, which is fx equals to 1 over 5x squared, you can see it is a compression.
Hi, my name is Karl, and I am going to be presenting about cubic function. Cubic function is fx is equal to ax to the power of 3 plus bx to the power of 2 plus cx plus d. The first example is not a cubic function because the x power is 4 but not 3, while the second example is a cubic function because the x power is 3. Simple. How does the graph look like? The graph looks like this. This graph is called a cubic curve. What can we observe from the graph? When the d value is 0, then the y-intercept is at 0, while when the d value is at 20, then the y-intercept is at 20. Now, I am going to explain about translation. There are 4 functions of translation. First is fx to the power of 3 plus k, where when k value is positive, then the graph will go up from its original point. Second is fx to the power of 3 minus k, where when k value is negative, then the graph will go down from its original point. Third is f in a bracket x plus h to the power of 3, where when h value is positive, then the graph will go to the left. Fourth is f in a bracket x minus h to the power of 3, where when h value is negative, then the graph will go to the right. Here are some examples. Very simple. We can see that when k is positive 10, then the graph will increase to 10 units, while the other graph shows that when k is negative 10, then the graph will go down 10 units. When h value is 4, then the graph will go to the left because the 4 is positive, while the other graph shows that when the value of h is equal to negative 4, then the graph will go to the right. Now, we are going to talk about reflection. What is reflection? Reflection is like a mirror, where it will move to the opposite way, but is still the same. So the function of reflection is just simple because it is negative x to the power of 3. Here are some examples. So we can see that when x is negative, then the graph will be inverted. Okay, I think that's all from me. Thank you.
Hi, my name is Fariz and I'm from Group 4, and today I'll be explaining about the translation and reflection of square root functions. The basic form of a square root function is fx equals to the square root of x minus a plus b, where the value of a and b will be the starting point of the graph. For example, the square root function of fx equals to the square root of x will have the starting point of 0, 0 and extends upwards and to the right. Square root functions can be translated the same way any other functions can. One of the ways is known as shift. For example, fx equals to the square root of x plus 1, where the plus 1 is outside of the radical, it will shift up 1 unit. And for negative 1, it will shift down 1 unit. For fx equals to the square root of x minus 1, where it is inside of the radical, it will shift to the right. And for positive 1, it will shift to the left. For the reflection of square root functions, when a negative sign is added in front of the radical, it will reflect the graph over the line of fx equals to b, also known as the y-axis. If the negative sign is put inside of the radical, then the graph is refracted over the line x equals to a, also known as the x-axis. However, if both negative sign is added inside and in front of the radical, then it will reflect the graph on both y-axis and x-axis.
So that's all from us. Thank you.